Hello everyone, welcome to the first Tidy Models tutorial called Build a Model. The purpose of this tutorial is to introduce users to the process of making models using Tidy Models, and we will be creating a simple linear regression model. So first we're going to start by installing the necessary packages for this tutorial, which are of course Tidy Models, Mixed, .whisker, readr, and rstanarm. Unsure how to say that one. Then we are going to read in the corresponding libraries, which can be seen here. This model is going to use data on sea urchins and explore how 3 different feeding regimes affect size over time. First, we can read in our dataset. The code R or read underscore CSV can be used with a link to a CSV file, which can be shown here. So I wanted to first show you what the columns are labeled in the dataset before we begin manipulating them to be easier to work on. So this column signifies the treatment, which is going to be either initial, low, or high. This one signifies the initial volume of each urchin, and this one shows the suture width of the sea urchin at the end of the experiment. So now we can begin manipulating the data set. We are going to start by renaming the columns. The treatment column will now be called food regime. The column labeled IV will now be labeled initial volume, and the column SUTW will be labeled width. Then we can mutate the food regime column, seen in this line here, which is currently contains character variables. So we're going to manipulate that into factor variables with 3 labels labeled initial, low, and high. Factor variables are easier to work with than character variables when creating models. So that's why we're going to do that. After running this code, we can see that our columns now have the newly assigned names and that food regime is registering as a factor instead of a character variable. So for each of the 72 urchins in this table, we know the food regime they were placed on, their initial volume, and their suture width at the end of the experiment. So before we begin modeling, we want to plot the data in order to get a visual representation of our data. After running this code here, we're going to get a ggplot with initial volume on the x-axis, width on the y-axis, and the colors are going to be representing the food regime that they were on. So each point represents one sea urchin, and the lines represent the trend of initial volume as opposed to, or as compared to final width of each urchin. So you can see the colors here. Dark blue is for the initial food regime, purple is for low, and orange is for high. All right, so after a quick glance, we can see that sea urchins with a larger initial volume tend to have a larger width after the completion of the experiment. However, the slopes of the lines representing linear regressions for each food regime look different, which suggests that there may be more at play than just the initial volumes of the urchins. So since we have both a categorical predictor and a continuous predictor in our model, a standard two-way analysis of variance model seems appropriate. Since the slopes for each feeding regime appear to be different, we will write a formula that allows for two-way interactions, meaning that our regression model can have separate slopes and intercepts for each food regime. This is achieved through the use of this formula right here, which will be placed into our model later on. I included it here because in the tutorial, it mentions it at this point, but it's not used quite yet. So when writing a model, we want to start by specifying the functional form of the model. Since we have a numeric outcome, width, and the model should be linear with slopes and intercepts, we'll be using the model type linear regression, as can be seen here. We'll then specify the method for fitting or training the model using the engine, which in this case is LM. Then the model can be trained using the code fit and the formula I mentioned above. So LM mod, and then using the code fit and the formula from right here. And then we also tell R that the data we want to use is urchins, which is right here, the one with the manipulated column names. All right, and this is what we get when we run that code. Then we can use the code tidy to see this in a bit more of a user-friendly way. All right, and this is what we get there. Just makes it more easy to understand what's going on in our model. Then this output can be placed into a box and whisker plot in order to visualize our results. Now that our model is complete, we can use it to predict the final weights of urchins not in our dataset. For example, if we wanted to predict the final weights of urchins that had an initial volume of 20 milliliters and were exposed to each of the 3 food regimes, we could start by plugging 20, volume of 20, into this code right here in order to create 3 new data points. The code expand grid is used to create a data frame with the new information provided. So in this case, we're left with a table of 2 columns and 3 rows. In order to get our predicted results, we can use the code predict to find the mean values for each of the food regimes at 20 milliliters of initial volume. This can be seen here. So we just use the code predict, place in our model, and then tell R that we want to use the data new points, which we created above. All right, so we are left with these results, but before we can interpret them, we need to also calculate the confidence intervals in order to communicate the variability. And we're going to use the exact same code here, predict our model, our new data points, but then we're going to specify that the type is confidence interval. Perfect, so now we have our predicted values and our predicted confidence intervals. So now we are going to combine the 3 tables that we just created, which is our new data points table, our predicted value table, and then our confidence interval table. So after running this code, we can see that we now have a table with 5 columns, and that is exactly what we were looking for. Perfect. Now we can create a ggplot with the table we just created with food regime on the x-axis and predicted value on the y-axis. So we're going to have points for each of the 3 predicted values, and then we're going to have an error bar showing our predicted lower and upper confidence intervals. And then we're going to label the y-axis with urchin size. All right. All right, that's it for running the linear regression model with a LM engine. However, I'm going to make another really short video on how to run this model with a different engine called STAN, which can be used if you want to use a Bayesian approach for your model.